Where'd she leave? Shelley.
Hello, how are you?
Oh, there you go. Okay, I'm good. It said you left.
Oh,
I hit admit and it said you left.
I don't know.
I don't know either. Okay, I got sharing on. Let me see what else I can do here.
You think we need to, it says recording.
Yep.
Do we have to record quite so early?
No, I just put it on so I'd remember. Let me turn it off. We're on.
All right. Well, good evening, everyone. Welcome to the November version of our 2021 WSST virtual conference. I'm Matt Lindsay, and I am the current president of the Wisconsin Society of Science Teachers. Tonight, we'll be hearing from Stephen Rogg, who is an educator, not an employee, who uses the free HHMI BioInteractive resources in online and blended learning, biology and ecology courses. And is a current STEM consultant here in the state.
And with that, I will share my screen. Okay. Are you seeing it?
No.
You're not seeing the slides?
Got share screen on.
Try it again. Yeah.
There we go.
Okay, it just took 2 tries. Okay, so what I wanted to do, so actually I was following up from the canceled conference last year and decided what I really would want to do, given the current circumstances, is focus on online and blended learning. So resources that are free that can help in the circumstances we're facing right now. So just as a quick overview, the tagline on BioInteractive is, I like this quote, which I never really paid attention to before until I was preparing for today. And empowering educators, inspiring students, real science, real stories, and real data to engage students in exploring the living world. And that I thought was really perfect, because those are the points I always try to make when I share BioInteractive with my colleagues, is that it's always based in real science. The materials, by the way, are developed by teams of scientists based on the real science, and then teachers, educators, active educators help develop the materials. And then, of course, they have professional developers that make it work and make it available on the website. So it's very much a collaboration with actual scientists, with actual educators, and with professional people that develop the resources professionally. So I wanted to share how to use the free resources for online and blended learning. And I want to, hopefully we'll focus on things that you can actually use. So just in terms of introducing myself, I've taught AP and Honors Environmental Science, AP Seminar and AP Research, Biology 1, and at the university level, science teaching methods and quantitative research methods. And in all of those courses, I've used BioInteractive materials over the last, I don't know, more than a decade, but I won't go for how many more. And then I've been in education for over 30 years, and high school experience, most significantly, recently at Gwendolyn Brooks College Prep in Chicago. And then I'm working with a school in Wisconsin right now, just north of here. So, so our itinerary, I thought 3 things, and people can chime in the chat, or there are just a few of us, so jump in. If something suits you, if you have questions or you'd like to do something differently, let me know. So 1, explore features of BioInteractive that support online learning and blended modalities. That's a word I don't usually use, but I thought I'd have fun with that. to share some research types. And this is where I wanted to do something special for WSST. So this carbon sequestration is something a colleague and I put together. So Ms. Holzer is in New Jersey, and it's a storyline and a set of materials and playlist that I think will be of nice value, and it's actually being presented on Friday at NABT. Wildcam Gorongosa is very different. It's more environmental oriented. Also, it's also environmental oriented. It's a nice series also. And this is getting presented also on Friday in Texas at the Science Teachers Association down there for Texas. So those of you who are, Wisconsin, you getting double the value for your bang. And then we did some work earlier this year on the online learning conference, the national conference on virtual labs. And so I thought I'd also share that playlist with you too. So in all of that, I hope you find some things of value, as well as kind of the general approach. And I really want time for Q&A. So I've allowed time for that. So I'll kind of go fast through the resources so you can ask questions and jump in as you wish. Everything we need is in this one-page guide. As I mentioned earlier, it's a Microsoft Word document, which you can now open in Google Docs, no problem. And but I made it that so you can download it and edit it and adapt it to your own needs easily. You can convert it to Google Doc or whatever. So that's available for you. Kathy's gonna, I think, put that in the chat, right? So we can is everybody able to access that? Looks good. Okay, so I'm gonna flip over there. And make us a little bit more room on the screen. Okay. So here's the first. Could we have kind of a thumbs up or of how many people are already familiar with BioInteractive? I don't have a formal poll. There you go. Okay. So of those there, so you can click on that link. Is that working for everybody? Okay. Thanks, Kathy. I'm going to watch your let you nod for me. So something this is the website's a little bit new. There is now a login. And so at the risk of you memorizing my password, I'll go ahead and log in. Did you get it? It was ... So if you log in, you can do things like save playlists. So I'll show you over here. You can have your own dashboard, and in your own dashboard, keep favorite resources and playlists. So some of what we're going to work from are playlists that I have created for us. Okay. And those playlists you can share with colleagues. So in your department, what have you, somebody could put together a playlist and you could develop a unit around it and share that playlist directly from the website. So that's rather nice. But if I go back to the home page and I'll just randomly pick a resource. They all tend to be set up in very much the same way. There's a description, tells you the type of resource. The materials will be over here. And I happen to pick one that doesn't have the folder, but many of the materials now have a folder to Google resources in which the student handout is converted to a Google Doc so that you can serve that through Google Classroom. So that's one way that I've really found is helpful for sharing these resources. And I saw actually on, I think it was NSTA's list or something just yesterday. I didn't get a chance to respond to it yet. Someone was asking about making an image so that you can edit that. And one trick I found, if you haven't, done that, is you can use in Google Docs, right? Use the drawing editor and copy paste images into that drawing editor, and then students can mark those up and save those images and respond back. So there are all kinds of tricks that we're learning, right, as we're doing the online work for that in this new world we live in. Okay, so a whole variety of resources, all very searchable, and can either be run online or downloaded, and you can convert to serve it up as Google Docs. So because it's all electronic native, it lends itself very well to integration into your learning management system and that sort of thing. So any questions about the site in general? I think it's very straightforward, but those are some of my favorite tools. Everybody good? Okay. So I did want to point out also, there's this educators' voices idea, and this one is all about what I was just talking about. It turns out, modifications for biointeractive resources for online classes. And Kathy just put her hand in front of her face. It turns out Kathy Van Hook and Chris Mansour co-edited this. So there's two educators that put this guide together for how to use biointeractive resources in an online environment. So if you don't like what I have to say, just go to this, and they have spelled it all out for you. Okay. So thank you, Kathy, for doing that.
Stephen, a question came in asking how easily can these biointeractives be integrated into Google Classroom?
Yeah, so we will probably get to, well, that answer actually is right here in this article. Okay. There are two ways that the PDFs are served. Some of the PDFs are PDF forms. So the students can download the PDF, fill out the form, save it, and then upload it back again to their learning management system. And that can be served out through Google Classroom. The other is the student work has been converted to a Google Doc directly. And so through Google Classroom, you just make that an assignment, and it goes, each student has their own copy. They complete it and it serves back. So I've done that in Schoology very, very, easily, and also in Google Classroom. So when I was in Chicago, we used Google Classroom. And so that's directly how I did it. The advantage there too is if I wanted to do a little bit of editing or a little clarification or add something to the doc, I could do that before I served out the template. Did I answer the question?
I think so. There's also a link that I will find and put in the chat that if you find a resource that has not been converted to Google Docs yet, you can fill out a form and request that it be converted to Google Docs. And it looks like Rit is looking that link up.
That link, it will take you to the request. So if there's something that's not in Google Doc that you want, it's there for you. Ah, see, I anticipated that question. See if I get any more right, though. Okay. So any other questions about that? Okay. So it'll help just to see some examples. So if we go down to the carbon sequestration, and I'm going to switch back this is really dangerous. Switch back to PowerPoint here. So I can share this great big thing. There's a link to this as PDF in the guide, so you can download this if you want it. This is the storyline that Missy and I put together on carbon sequestration. And we did something that's a little bit different and unusual. We start with the concept of photosynthesis. And we sort of use that as an organizer, but the real thread, if you will, the anchoring phenomenon for this whole thing is carbon sequestration. But we kind of question, can you sequester enough carbon with photosynthesis to take care of global climate change, for example? Okay, without diving into that, we just kind of ease into this idea. So we start with the famous, people are probably aware of Minds Our Own or Private Universe, the classic work that was done by the Harvard Smithsonian Astrophysics Group. Okay, if that all sounds strange to you, they asked MIT and Harvard grads on graduation day where the weight in a log comes from, and they just handed them like a 10-pound log and said, where does that mass come from? And I realize I'm confusing mass and weight right now, but I know what I'm doing. I'm a professional. And of course, the answer, which I have done this with high school students, I have done this with all the way up to graduate students. And it's just remarkable that you get the common answer: water, sunlight, air, soil. The same thing that fourth graders will tell you, right? Oftentimes with adults. So it's a really fun one to start with, to kind of demystify that photosynthesis, in fact, that famous equation that we memorize but don't quite understand, simply says that, we take carbon from the air and polymerize it to make, cellulose, for example. So a lot of times we teach things, students don't quite grasp it. So we start with that because we feel that's that's kind of a nice way to start. And then we'll look at that. Sorry about that. And then we build questions into looking at both spatially over the planet, but also over time. So temporally, in deep time of history, how has atmosphere changed? And that brings in like a good use of the Keeling curve. So I'll show you how these resources build. And the story builds, and in the end, we look at a more systems level view of a model of how carbon is sequestered and released in global systems and our local communities. And so the idea is to start from naive to very detailed, complex understandings of a very complex issue. So that's what this storyline does. I'm really excited about it. I kind of love how this came out. We worked on this for about 2 years. So there it is. So let me pop back then to the storyline itself. So that was the overview. And just share with you that this link will take you to a playlist on the BioInteractive site that I put together for this. Okay. So you'll see that it starts with the idea of photosynthesis, uses the Keeling curve to introduce, where is carbon dioxide in the atmosphere, what's going on there. So to get to that, by the way, we thought it was fun to, first say if photosynthesis is sucking carbon dioxide out of the air, and we have all these plants doing that, aren't we running out of carbon dioxide? So these are things kids wouldn't have thought about, right? But it's fun to think about. And then if you think about it and then you see the Keeling curve, you say, well, that's not what's happening. But there are a couple of things happening here. There's the Earth breathing, that signal. And then there's the increase over time of carbon dioxide concentration. And then we go back in geologic history because that raises the question, well, is this something new or is this just another cycle? Okay, so looking at geologic history, excellent resources to pull that out. Earth Viewer, one of my favorite things on Earth. It's like Google Earth, but for all of Earth history. So if you haven't used this resource, it is amazing. And you can see how gas levels have changed over time. we use the Winogradsky column, some of you might be familiar with, for creating a model system in the classroom. So microbes responding to the conditions in the column. So that, then start tying to global issues like coral bleaching, how photosynthesis is actually impacting algae. This is recent science. These are graphs that are real data, recent data, that students, interpret. So they learn how to, develop this kind of literacy and data fluency. And then we end with the understanding climate change, where students actually build a complex model. So that's the playlist that's affiliated with this. But there's a guide for it, just like this guide we're using right now. And this was put together for Texas Science Teachers Association. So I'm sharing it with you because you deserve what Texas gets and what the nation gets. So Wisconsin's getting it all is what's happening here. So there's the expedition guide. Whoops, I hit the wrong one. WildCam Gorongosa. I might have the wrong link. Did I go? Oh yeah, no, I just went to the wrong one. Sorry about that. That one we're getting to. Here's the photosynthesis guide. Okay. So this is just the detail that goes along with that overview we just saw. Okay, so that how that storyline plays out. Okay, obviously we have limited time, so I'm not going to walk through that anymore, but everything you need is here. And again, you're welcome to capture this and edit it, make it your own. No extra charge. So everything on BioInteractive is free, right? And because their mission is to serve science education. So I like to capitalize on that. Okay. So any questions on the carbon sequestration idea? Anybody see how that could be useful or do something similar? Okay, if you're happy, I'm happy. And feel free to put comments in and Kathy will stop me too. Okay, so finally there's the WildCam Gorongosa. Again, there's the playlist of the resources, but those are also embedded in the guide, which I already opened up once, but let's do it again. Okay, so this is a one pager, but it's on page 2, the good stuff. And this one is around a story. If you're not familiar with Gorongosa, you haven't been there. It's a wonderful case study. It's a national reserve, national park in Mozambique. But it was devastated. The large mammal wildlife was pretty much 90% gone after Civil War. And, it's an amazing story, but there are layers of the story in which, the students can also identify with. And I think it's a wonderful case to see how an ecosystem or an environment has been devastated by war in this case, and then is coming back because of efforts for recovery. And the recovery is just fascinating. It's really remarkable. This has been featured on some PBS stories. In fact, one that was released just a week ago in Wisconsin public station, and I'm forgetting the name of it. But there was a show just on Human Planet or something like that. And in the first episode, it's 2 episodes have run now. The first episode, one of the segments was about Gorongosa. It's really an interesting case. So the way this one works is students fly there using Google or Google Earth to find the place and discover that it's not near here, it's in Mozambique. Then they use Biome Viewer, which is like Google Earth for biomes. another really cool resource, and interactive maps to start learning about that local place and its biomes and what you kind of find there. There's a really wonderful film called A Biologist in Gorongosa. That's a longer film, so it can be assigned to do at home, or if you're virtual anyway, it's going to be at home. But that has a cool segment in it where this guy named E.O. Wilson, yes, that E.O. Wilson, has taken kids at Gorongosa out on a BioBlitz. And it's a really nice segment in there. And so I actually like to take students out on a BioBlitz. And I did this with students in Chicago. We did BioBlitz in the Pullman neighborhood, which is a famous place. It's a national monument now. It's where Labor Day came from. So if you know about the Pullman Porters and that history. But you can do BioBlitzes in urban areas as well. So no problem in Milwaukee, right? There are places where you can go do BioBlitz. And Madison and here in Kenosha. So so it's a way of, tying what they're learning about this case to what's happening in their local environments. And then the real investigation begins. So what has happened there is wildcam data or camera trap data has been used to collect, it's over like 40,000 records of mammals over a couple of years. And that data is actually available. You can download it. This link here takes you to my Google Sheets workbook, where I've actually, kind of like solved the problem. Don't share this with your students. But I've downloaded the data a couple weeks ago, the most recent data. But so students can, first of all, practice using the camera trap data, identifying animals from photos. They do that online, download the data, analyze the data, and build ecological pyramids. So this is what happens here. Because this, of course, is just an overview, our time together. I'll open it and I'll kind of show you the end result. So lots of data. Some of the answers you can get by running pivot tables. So here I've just run a table. Wait for that to load. To answer this question, which is in the student guide, students are asked, during which season is the abundance of animals in the limestone gorge vegetation type the highest? Okay, so running a table from that data set, we get a real quick answer. It's obviously during the dry season in July and September. Okay, so I know I'm giving you just kind of an image of what's there and what happens. This other pivot table is actually, if you do this activity, will help you. You have students breaking up to find out, how many of each species are represented in the data set. So, there are a lot of elephants, elephant sightings, right, over time. And then that's converted to biomass. And so this is the data analysis part of finding how many animals were sighted, what is the average biomass for an animal, and calculate total biomass for that animal. And from there, so here's where you need some help, because you need to look up the average biomass. That's given on the site, so students have to do that. In some cases, I used the Encyclopedia of Life and some other sources to find average biomass of some of the animals. So this is like an entire unit, right? And then you can plot that. And it turns out with trophic levels, I use the key 2, 3, and 4, total biomass. And you see that looks kind of like half of a pyramid if you just do a bar chart, right? But I also found a way to trick Google into making a pyramid. Okay, so here's how I did my trick. And you can see the biomass pyramid. Okay, so I did that. That's for you. I think it was a lot of fun, but it engages students in taking camera trap data, identifying those animals, downloading the data from the massive data set, and getting answers from it. And of course, they can explore other questions as well. So So that's how that one works. You know, I realize there's a lot there. That's like a whole unit, as was the other one. Any questions about that? Okay. Is anyone getting dizzy from how fast we're going? So like I said, this is
quick
for
question.
you. Yeah.
The WildCam is an active cam that they can also look at in real time.
So those not any longer. So the photos that are available on the site have all actually at this time have been identified.
Okay.
So they
But
can
you could
practice
link it to
identifying
some,
them.
you could easily link it to some Wisconsin cams that are out there in the field and make it local too, that the same type of research could be done in the northern woods or whatever.
Yeah, there is, and I forget the name of it. There's a Wisconsin data set. And actually, there's a colleague of mine here at Carthage College locally that's been doing the wolf study data using sound data. Those are all available. It's wild something for Wisconsin. Wild Wisconsin or wild? Does somebody know that one? I have that bookmark, but absolutely you could do that. Yep. Thank you for that. Absolutely. Okay. So we're good with that? Okay, so the last kind of resource I thought folks might like to see are the virtual labs, if you're not already familiar with them. And so just to make it easy, of course, you can go to the website and search for virtual labs and you'll come up with this list. But just to make it easy, I made a playlist of 7. So there's the bacterial identification, cardiology, immunology, lizard evolution, and so forth. So, so those are also there. And obviously, you know, virtual labs are all about being able to do online labs. Okay. So I didn't have any time there because I just wanted to share that. So finally, could we, talk about your questions or how you're using resources right now to?
Well, I think right away when you first showed some of the resources, the day the Mesozoic died popped up, and that's one that we've used for the last 3 or 4 years in biology. We've tried to integrate some earth science standards into our biology class, and so we do that right before we do evolution. We kind of do a little bit of earth science and history and age of the earth. And then we kind of pull that in because the kids are always interested in how did the, dinosaurs and, what happened to the dinosaurs. So we use not exactly the way it's set up, but, we've modified it a little bit to work with our population. But
yeah, absolutely.
We used to use something different that, was about that same topic, but I went to a WSST session, I think, about this, somebody presented on how they use that unit, and we've been using it probably for 3 or 4 or 5 years since then, and it's so much better because the kids are taking data and measuring the size of the KT layer, and we do the thing about the foraminifera and that they're big and varied before the collision and tiny and not so varied after. So just so many pieces of data that fit together, and then we show the pieces of the video. So we do, we do chunks of that and we kind of chunk it out for the kids. But that's one of my favorite things to do with kids because they, they get to see I think they go to Spain and they go to Italy and the layers, and they're in Texas, and so it's a really cool way to put all of that together and make it kind of meaningful for the kids, that thinking way back when with dinosaurs and how can you see that today? So I'm really excited to look at some of these other things that we could be able to integrate. You know, it's like anything, you get kind of stuck in what you're doing. And you know, there's great stuff out there, but you have to go out there and find it, and then, you know.
Yeah. It takes time, right, to incorporate it.
Right.
And yeah, so,
That
you know,
makes
putting
you,
these
like, excited.
storylines together took some time, as you can
Yeah.
imagine.
Oh, yeah. So
Um,
that's one I use that I really like.
Yeah, I that's a really good one. And I love the video that goes with that. I was going to say, I was going to pair. This, by the way, of course, has the storyline has other resources in it too, besides what are in the Earth Viewer. I mean, are in the playlist. But there we have Earth Viewer, which would pair well with the Mesozoic, the day the Mesozoic died, because you have the Earth's history. I can actually launch it for you, but it also, you have the extinction events. So we don't need to see the overview. So this is really, you know, really fun to see how the Earth changes over time, and the warming Earth, and plays like a movie. So did I go the wrong direction? There we go. Through all of Earth's history. So monitoring both how the atmosphere has changed, how the land masses have changed, and where the extinction events happen. So you can get in there that sense of, you know, the Earth, what was the place like when these extinction events happened? So that's fun for me, you know, just a thought.
So, Stephen, I teach AP Summer Institute in biology and have for about 8 years now at UW-Madison. And every year I'm surprised at the number of upper level biology teachers who do not know about HHMI. I mean, it's not a lot,
Yeah.
but I'm still surprised that anybody who's a teacher does not. Everybody should know about it. So I always promote it too there.
Oh, thank you. Yeah, I mean, I you know, for me, it's been a lifesaver a lot of times, you know, just in terms of having quality resources. You know, I mean, for me, that's the issue, that they're you know, they're vetted. It's good science. Teachers have worked through the activities, and and getting to know that community of teachers who've been involved with this. You know, it's an impressive group. I'm amazed they let me come along, but yeah, so the fantastic materials. With that, well, let's see, where did I lose my there we go. So any other questions?
I'll ask a general one, and maybe Rit might be the one to answer it because she's with HHMI. But I know when Sean took over as vice president for education, and I talked with him about this, he really wanted to do a lot of movie video type resources. Is that still the thrust of a lot of the education efforts at HHMI?
So unfortunately, I recently joined HHMI. Well, it's been a year, but it feels pretty recent. We do have plenty of movies, but I can't say that that's the direction that we are focusing on. But we have been putting a lot of movies out recently.
You might be aware too of the affiliation with Tangled Manx Studio. I mean, as a branch. And then
okay.
Yeah, and then if I reach behind me, I have copies of Inventing Tomorrow, which is playing now. Actually, NSTA is, I believe, right? NSTA is serving it, right?
It's NABT, so it's movie night on November 6th. Yep.
NABT movie night. I know they're all coming up in the same series here. So yeah, so NABT is making that available. And that movie, if you haven't seen it, it's about groups of students from around the world, including the United States, who are competing in the Intel. Kathy, what's it called?
I'm sorry,
the
what?
national, the Intel. Why am I blanking on that? The big international science fair, Intel.
Right.
Its
I
name
think
changed. That's
they've
why I'm having
changed the
trouble.
name of it, haven't they?
Yeah, they changed the name. That's why I'm blanking on it.
Mm-hmm.
Let me reach behind me here. Hang on.
Uh-oh, he's diving into Lake Michigan.
It was Intel ICEF, but I think it's got a different name now.
No,
it
I
is.
think it's ICEF, yeah.
It still is ICEF. Okay. Something else changed. Intel ICEF. So they're competing in that, and so there's the commercial. Oh, I guess the screen thing has to lock in on it. And it's a good movie. I think it's a little slow in the middle, but don't tell anybody I said that. But it's really interesting, and it's eye-opening in the sense that it really examines the world we live in now. You know, where where students can do very important research in environments that normally aren't all that enriched. But it's an amazing world we live in. And I'm a real believer in student research and giving students a chance to work with authentic data and tackle real problems because they're able.
I recall seeing a video movie of some Malaysian students working with local fishers and talking about bioaccumulation of toxin. Is that the movie? Is that part of that series?
Yep, that's one of the groups. Yeah,
that's an amazing story of these young Muslim girls really challenging the fisher community in their country. I just was so impressed with that.
Yeah, they're mining lead and polluting the water, the coastal water, right? If I remember that group. And yeah. And there's a team from Mexico and a kid from Hawaii that's doing interesting work. Yeah, groups all over that. Yeah, it's a series of cases. Really interesting story. So long answer to Rit's question. There's filmmaking happening in collaboration. And they collaborate also with PBS, so it comes out there as well by some magic. So with that, I guess, if you're happy, I'm happy. And there's a feedback form if you don't mind clicking on that link or using the QR code to provide some feedback on the session. That's very helpful. And HHMI, BioInteractive, they do take that seriously. So I know that they will. If there's something you need or something you found interesting or lacking, they will definitely take that seriously. So if you don't mind doing that. And while you're doing that, I'll see, did I have, so we still had the guide. Yeah, in case you don't already know, there's the website, there's a Facebook group, there's a Twitter group. So I actually do follow the Twitter group because things are announced that, even though, I pay attention, oftentimes there are new resources that come up that I have no idea about. So the Twitter group's really helpful. And yep, and then the feedback, please. Okay.
Mr. Rogg, thank you for sharing your time and effort and all of the great work that you've been doing with our membership this evening. If there are other questions for him, please ask either in the chat or unmute yourself and ask those questions. Thank you.
Thank you, Matt.
Yes, thank you, Stephen. I was doing the survey. So very helpful. And like I said, I'll put the link up or get our webmaster to put the link up, and hopefully others can help. And we had a late joiner who, Jennifer, small group, but Jennifer, where are you teaching at?
I'm at in Appleton.
Great.
Yeah.
You can look for the link and you can see the first part of the presentation that you missed. And Shelley, you'll be sharing, or at least we'll post the resource guide that Stephen put together, correct?
Yes, I had to find my unmute button. Yes, we will. We'll have all of that stuff out linked on the WSST site.
Okay.
So great.
Thank you.
I encourage everybody to do the survey, because having done those, you need to have data to support the effort, and it was very informative. Thank you. And if there are no other questions, I'll stop the recording, and the next session is a different Zoom room. And Shelley, what's it on? I already forgot.
This was in the next one is on Pear Deck, and using that in your classroom. And if you want to stop recording there, Kevin, I mean, you can keep recording, but I can put a link to that Zoom chat or